What's up, guys? Mr. Teen Tutor here, and today we're going to be talking about how to analyze parallel circuits. I hope you guys are in the mood to do that right now. Here's our nice parallel circuit, and we need to find three things. We need to find the equivalent resistance, we need to find the total current for the circuit, and we need to find the voltage and current for each resistor. That's key right there for part 3, which is what we'll get to later in this video. Before we begin, let's compare what you guys learned about series circuits, and then you're gonna learn about parallel circuits. So let's start series circuits. Now, in my video, or you may know this already, you know that the total current is equal to each current in each resistor. And you also know that the V source, which is again the battery, is equal to the voltage in resistor 1, so on. However, in a parallel circuit, it's a little bit different. Let's see if I can squeeze it here. Alright. In a parallel circuit, the total current, T represents total, is equal to the current in resistor 1 plus the current in resistor 2 plus the current in resistor 3, and so on. And this right here is known as Kirchhoff's law. We're going to be using that today. Now if we come over here, you guessed it, it's all flip-flop, so V source is equal to V1, which is equal to V2, and so on. So we're going to be using this concept, and we're going to be using this concept, and actually another one, which I'm going to show you in a little bit, to solve this problem. Let me erase all this. I hope you guys understand now the difference between the equations. Alright, so let's go to our first problem. Or rather part. Whatever. We need to find the equivalent resistance. Now, this is just a fancy way of saying total resistance. But they call it equivalent resistance because we're in a parallel circuit. It still means the same thing, so don't worry about that. If you want to make a note of that, go ahead, because it'll help you out. Now, in a series circuit, we learned that the total resistance is equal to the resistance in resistor 1 plus the resistance in resistor 2, and so on. But in a parallel circuit, it's a little different. This time it's 1 over Req, which is again RT. And that's equal to the reciprocal of resistor 1, the resistance in resistor 1, plus the reciprocal of the resistance in resistor 2, and so on. So we're going to be using this equation to solve part 1. It may look a little bit daunting, but don't worry. You will get through this, and there will be no issues when Mr. Teen Tutor's around. So equivalent resistance. 1 over Req, and remember that, it's a reciprocal. This is where you could easily make careless mistakes. Don't make careless mistakes. Mr. Teen Tutor is not an advocate of that. So this is 1 over 10 plus 1 over 12 plus 1/6. Now I said that the resistor with the resistance of 10 ohms is resistor 1. It doesn't have to be that. It can be any one of these. It doesn't matter because addition is cumulative. That's what I meant. So now, what do you do when you add 3 fractions or more? You find the common denominator. Now one of you might say, oh, 720 is the common denominator, which is true, but we can find a common denominator that's much smaller and closer to these 3 numbers. Well, I'm thinking of 60. 60 is a good number. So what's 1/10 of 60? 6. So 6 plus 5, because 5 6 is 1/12, plus 10, because 10 over 60 is 1/6. We'll add these together, 21 over 60, and even though we're in physics, please reduce. Because physics, as you know, is still math-based, and you should still apply certain math concepts and rules here. Now, don't be that guy who says that the equivalent resistance is 7/20ths or 0.35, because you're wrong. Because you forgot to realize that it's actually 1 over Req. That's where people make careless mistakes. And like I said, I don't want you guys to make those careless mistakes. So you're going to set 7/20ths equal to 1 over Req. So what would you do in normal mathematics when you have this? You would cross multiply and isolate the variable. So let's just do just that. So when I do that, I get 7, let's go up here. 7 Req equals 20. What would you do? Divide both sides by 7, and I'm going to use my handy dandy calculator here. By the way, I have the TI Inspire. I like it a lot. It's pretty cool. Now for the calculator, I'm going to round to the last digit it has on there, because this will help us find the other two things with precision. But when you write your answers, you can round it to the nearest hundred place. So if I divide both sides by 7, the equivalent resistance turns out to be 2.85714. That's equal to Req. Again, 2.85714. Now we're going to use this to find the next components. So I hope you guys understand now how to find equivalent resistance. Alright, now let's find the second part. Again, make sure you make note that the equivalent resistance, or RT, is equal to 2.85714 ohms. Don't forget the units. Now, we need to find the total current for the circuit. So remember, in a series circuit, you had to find current by doing V source over R. Well, don't worry, there's really no change here. In a series circuit, it was just R, which in parentheses was RT. But now, in this problem, we're going to just put V source over R EQ. So when we do that, we get I equaling, our V source is 24, and you can write the units here, divided by 2.85714 ohms. See what we get here, and once again, once you get your answer, make sure you include the units. That's important. Alright, so the answer was like 8.400001, so just put 8.40 down. That's fine. So this is the total current. Now this is not 840, it's 8 point. Now we need to find the current and voltage in each resistor. But hold on a sec. At the beginning of the video, I said that the V source is equal to V1, V2, and V3, which means that the voltage in each resistor is 24 volts. And if you remember from the last video, or if you already know this, current is equal to V over R, which is just like this, just like simplified version for just the resistors. Alright, so let's divide the pairs of numbers, and we're going to get I. So 24 divided by 10 is 2.4 amps. Again, include the units. 24 divided by 12 is 2 amps. And 24 divided by 6 is 4 amps. Now, if you remember what I said at the beginning of the video, the I total has to equal I1 plus I2 plus I3. Well, this is a good way of checking our work. We got 8.40 as the total current. So now let's add up this, this, and this. 6 plus 2 is 8. Oh. Oh, I'm sorry. I'm sorry. My bad. I did 6. That's the ohm symbol. Ignore that. What I meant to do was 4 plus 2 plus 2.4. Never mind, guys. I was right. Just ignore the 6 right here. That's for resistance. 4 plus 2 plus 2.4 is 8.4. So there you go. They equal 8.4, so you know that this value right here is correct. So I hope this video has helped you out with analyzing parallel circuits. As I said at the end of the series circuit video, it is a little bit more complicated than this, but as Mr. Teen Tutor here, I tried to make it sound very easy to you guys. Now, if you have any questions for me, just write on my YouTube channel. Thank you.